Hi viewers, I am Dr.G.SWETHA, Assistant Professor of Physics, A.D.M.COLLEGE for Women, Autonomous in NagaPattinam. Today we see the topic is nanotechnology. The topic of the day is introduction, definition, history, timeline, tools and technique, carbon nanotubes, nanorods, nanorobots, and approaches used is top-down methods and bottom-up methods and materials used. The application is drugs, fabrics, mobiles, electronics, computers, and other uses nanotechnology in India and possibilities of futures. The first nanotechnology. The nanometer is a unit of length in the metric systems equal to 1 billionth of meters 10 to 9. The technology is making usage and knowledge of tools, machines and techniques in order to solve a problem or performance a specific functions. The nanotechnology refers to the branches of science and engineering devoted to the designing, producing, and using structure, device and systems of manipulating atoms and molecules at the nanoscale. That is, how having one or more dimensions of order of the 100 nanometers or less. The next slide, definition. The nanotechnology is the study of manipulating matter on the atomic scale. The nanotechnology refers to the constructing and engineering of the functional systems at very micro level, or we can say at atomic level. The nanometer is 1 billionth of meter, roughly the width of 3 or 4 atoms. The average human hair is about 25,000 nanometers widely. The more specializedly, nanotechnology is the imaging, modeling and measuring, designing, characterizations and the productions and application of structures, device and system by the controlled manipulations of the size and shape at the nanometer scale that produce structures, device and systems with at least one novel superior characteristics or properties. The next, history. The history of nanotechnology is the first ever concept of presented in 1959 by famous professor of physics Dr. Richard P. Feynman. The inventions of scanning tunneling microscope in 1000. Next, history of nanotechnology is first ever concept of presented in 1959 by famous professor of physics in Dr. Richard P. Feynman. The invention of the scanning microscope in 1981, then the discovery of fluorescence in 360 in 1985, that lead to the emergence of nanotechnologies. Then terms nanotechnologies had been coined by the Nanotechnologists in 1974. They mainly argue that is the history of nanotechnology starts with Richard Feynman's classically talk in the December 1959. There is plenty of room at the bottom at invitations here to enter the new field of physics. The next, the early 2000s also say the beginning of commercial applications of the nanotechnology is, although this were limited to bulk application of nanomaterials. The silver nano platform for using silver nanoparticle as the antimicrobial agent. The nanoparticles based transparent sunscreens and carbon nanotubes from strains and resistant textiles. The next of classifying of nanomaterials. There are the different types of nanomaterials and different ways classify them. The first one is natural nanomaterials and the second one is artificial nanomaterial. The first one is natural nanomaterial, as the name suggests, or those that occurs naturally in the world. These include the particles that make up by volcanic ash, smoke, even some molecules in our bodies, such as the hemoglobin in our body. The brilliant color of peacock features are the result of spacing between the nanometer scale structures on their surface. Next one is artificial nanomaterial, or those that occur from objects or process created by the people. For example, they include the exhaust of from fossil fuel burning engines, some form of pollution. But while some of this just happen to the nanomaterials, the vehicle exhaust, for instance, was not developed as one scientist and engineering or working to create them for use in the industry of manufacturing to medicine. Next, tools and technology. There are the several important modern development. The first one is atomic force microscope and the second one scanning tunneling microscope. The first one is atomic force microscopic or scanning force microscopic is a very high resolution type of the scanning probe microscope with the demonstrated resolutions of the order of fractions of the nanometer more than 1000 times better than the optical diffraction limit. The second one is the scanning turning microscope SCTMs or scanning probes that enhance launched nanotechnologies. The scanning tunneling microscope is types of the microscope is used to the imaging surface at the atomic level. Next one is the various technology of nanolithography such as the optical lithography, X-ray lithography and dip and nanolithography and electron beam lithography. The first optical lithography is photon based techniques. The comprised of projecting an image into the photosensitive emulsions. The coated on 2S substrate such as the silicon wafer. The next one, X-ray lithography. The X-ray lithography is a process used in the semiconductor device. The fabrication industries to the selectively remove the parts of the thin film of photoresistors. And the next one, dip and nanolithography. The dip and nanolithography is a scanning probe lithography techniques where at atomic microscope dip is used to create the pattern of directly on the range of substance with a variety of lengths. The last one, electron beam lithography, is a inkjet printer were also the developed. The lithography means construct is typically the transfer of pattern into the photosensitivity material by selective exposed to a radiation sources such as the light. Then the next slide, carbon nanotube. A carbon nanotube is one of most important nanomaterials. Before 1991, only two main allotropes of carbon. This till 1991, the Japanese physicist the Zumio Lisna inverted C and T or another inverted in the allotrope of carbon. The second nanotubes are formed by the floating or rolling two-dimensional graphite into the cylindrical shape structures. The nanotubes are hollow from inside. The diameter of the nanotubes is around to 1 to 3 nanometers. The length of the carbon nanotubes is much higher than its diameter. The nanotube length generally goes to few micrometers. In short, we can say that the carbon nano is loaded from the two-dimensional graphene sheets. The CNT exhibit the extraordinary mechanical properties. The next properties of carbon nanotubes. The highest strength to the weight ratio help in the creating lightweight spacecraft. The second one is easily penetrated membranes such as the cell walls is helping the cancer treatment. The third one, electrical resistance changing the significantly when other molecules attracts themselves to carbon atom, help in the developing sensor that can detect chemical vapors. And the crystalline structures of the carbon nanotube exist in the form of the regular exosomes. And carbon nanotubes are elastic, and carbon nanotubes are good conductor of heat and also the good electrical conductivity. The Young's modulus is the carbon nanotube is the high of the Young's modulus. The Young's modulus of carbon nanotubes is around 1 pascals, which makes carbon nanotubes 10 times of stronger than the sealed. The carbon nanotubes are chemically neutral, so they are the chemically stable. Therefore, the carbon nanotubes restricts the corrosions. The next application of nanotubes. The breast cancer tumor destructions and windmill blades and filtrations and carbon nanotubes as the nanocylinders and aircraft stress reductions. The best cancer tumor destructions is the nanotubes are used to destroy the breast cancer of tumors. They play with the antibody. The antibody along with the nanotubes is affected to the protein by the cancer cells in the body. The nanotubes absorb the laser beam killing the bacteria of tumor. The next one, windmill. The windmill blades is a hollow tubes are also used in the windmill blades because of their low weight. It increases the efficiency of the windmill and helps to the produces the more electrical at the faster rate. The third one, filtration. The filtration is the carbon nanotubes can be used in the separate particles of the size greater than of the diameter of carbon nanotubes. During the filtration through them, they can also be used to trap smaller sized ions from the solutions. The fourth one is carbon nanotubes or the nanocylindricals is a gas like H2 for energy battery of vehicles can be safely stored into the carbon nanotubes, and also the problem of H2 storage hazards can be solved in the carbon nanotubes as the carbon nanocylinders. The fifth one is aircraft stress reduction. The stress reduction is nanotubes are also used in the space and the aircraft to reduce the weight and the stress of the various components working together. There are also the carbon nanotubes. They are used in the catalyst in some reactions. They are also used in drug delivery systems and the applications related to the conductivity of electronics. The next, the types of the carbon nanotubes. The first one, single-walled carbon nanotubes, and the second one, multi-walled carbon nanotubes. The single-walled carbon nanotubes is it's represented as the SWCNT as a single-walled carbon nanotubes. They exist the 1,2-D structures. Some example of the single-walled CNT or armchair and zigzag single-walled carbon tubes. The second one, the multi-walled carbon tubes, is represented as the MWCNT. It is composed to several nested of carbon tubes, nanotubes. These types of the nanotubes has two diameters, one known as the outer diameters and another one is known as the inner diameter. For example, the multi-walled carbon nanotubes is a chiral multi-walled carbon nanotubes. The next one, nanorod. It's a quantum dots. The nanorods are one morphology of the nanoscale object. The dimensions range from 1 to 100 nanometers. They may be synthesized from metal or semiconducting materials. The combination of ligands act as the shape controlled agent and bond to different fact of the nanorod with different strength. This also different phase of the nanorod to grow at the different rates and producing elongated to object. Next, uses of nanocarbon tubes. In display technology, because the reflective of rod can be changed by changing their orientation with the applied electrical field. The next one, micro electromechanical systems of means. The last one is cancer therapeutics. They mainly used in the cancer therapeutics for the carbon nanotubes. The next one, nanorobots, nanobots. The nanoid robotics or for short nanorobotics or nanobotics is in emerging technology field creating in the machines or robots whose components are at near the scale of the nanometer. Not to the confused with this the fictional nanorobots for mechanical technology researchers or nanorobots or nanobot is popular for molecules with a unique property that enables to be the programmed to carry out the specific tasks. This nanorobots are a reality and are beginning actively reached and developed. And the close to the scale of 1 to 9 nanometer, the largely is the R&D phases, and the nanorobots of 1.5 nanometer across, they capable of counting specific molecules in the chemical sample. Since nanorobots would be the microscopic in size, it would properly the necessary to very large number of them to the work together to perform microscopic and microscopic tasks. The capable of reflections using the environment resources and the applications of the nanobots is detections of toxic components in environment in drug delivery and biomedical instrumentation. The next one is approaches in a nanotechnology. The first is bottom up. In a bottom up approaches, different materials and devices are constructed from the molecular component of their own, and they chemically assembles of themselves by recognizing the molecules of their own breed. For example, the molecular self-assembly or wax and creep based pairing under nanolithography. And the image is assembly from the atoms of molecules into the bottom up of nanotechnology. The advantages of the bottom up is they make decisions about the resolvable low level of analyze them, decided how they will be the put together to create high level construct. The second one, top down. The top down approaches nano object and material are created by the large entails without bouncing in atomic reactions. Usually top down approaches is practiced less as the compared to the bottom up approaches. The solid state techniques can also be used to create devices known as the nano electrochemical systems or MEMS, which are related to the macro electromechanical systems or MEMS. The MEMS become the practical one day could be fabricated using modified the semiconductor device fabrication technology, the normally used to the electronics. The images in the size and reductions to the nanoscale for the assembly of top-down method. The advantages of top-down method is breaking the problem into the parts of help us to identify what need to be done, and each step or refinement the new parts will become less of complex and therefore easier to solve. The some parts may turn out the resolvable and breaking the problems into parts allow more than one person to the solve of the problem is top-down technologies. The next is nanomaterial synthesis. The first, the top-down approaches. These approaches are referred as the physical method for like bulk materials, powder form and a nanomaterial. The second part of bottom-up approaches is referred to the physical and chemical methods. Is construct the nanomaterials and clusters and atoms or molecules. The next slide, application of nanotechnology. The application of nanotechnology is referred as energy, medicine or drugs, nanotechnologies, nanobiotechnologies, nano device, optical engineering, defense and security, bioengineering, cosmetics and nanofabrics. Is all are the innovative applications. The next, nanotechnology in India. The IIT Mumbai is premier organizations in the field of nanotechnology. The research in the field of health, environment, medicines are still on. Starting the 2001, the government of India launched the nanotechnology and nanoscience and nanotechnology initiative of NSIT. Then in the 2017, the nanoscience and nanotechnology missions 2007 was initiated with the allocations of ₹1,000 crores for a period of 5 years. Then mainly objective of nano missions are the basic research propagations, promotions, the infrastructures, development of carrying out front-ranking research, the development of nanotechnology and their applications, the human resources development and international collaborations. The next, possibilities for the futures. And nanotechnology may make it the possible to manufacture lighter, stronger and problemable material that for the require less energy to produce than the conventional material and that promise greater fuel efficiently in land transportations and slips and aircraft and the same space vehicles. And the next, the future of nanotechnology could very well include the use of nanorobotics. These robots have potential to take on the human task as well as the task that the human cloud could never complete. The rebuilding of the depleted zone layer could potentially be able to the performed. Thank you for watching.